Here we want to do classwork 6, in which we are gonna solve the production and inventory model that we just made, and we are gonna solve it with Excel solver. Okay, all the steps are similar to the previous classworks or previous models that we did with solver, and so this video should be shorter because I'm gonna skip explaining some of the steps. But before we start, I want to also explain that see, I'm here for the demand nodes that starts from node 5 that we have it here. You see, there are only two variables, but with demand 6, that is with node 6, we have three variables: x26, x56, and x67. The reason is this: because it is the node 5 is the first node, is the first quarter node. There is no previous node to get any transfer from, so that's the reason we have for node 5 no transfer. So only with two variables we can get it done. But for node 6 and node 7 we have transfer from previous quarters. So as you can see, for x26, not only for node 6, not only we have x26 as inflow, but also we have x56 as inflow, because this is the amount of carpets are coming from the previous period. And also the rule that I told you applies here to write the constraint. For example, if I want to write it for node 6, let me write first the inflow, that is x26 plus x56. It's a transshipment node, so the amount of inflow must equal the outflow. So x26, as you can see here, inflow from here, and also x56 inflow from here equals the outflow that we have. One outflow is 500, that I'm gonna write it, and the other outflow is 67, exactly the same as previous network models that we did together. I wanted to mention that also here to make sure you know how to handle this type of models from different perspectives. Now let's go and handle our Excel solver model. We have the raw structure of our solver model. As you can see, it is empty. I didn't fill up any part of it, and let's fill it up. For the objective function, we are going to do the same as before. We start with equal, and we do 2 times x15 plus 5 times x26, and continue like that. Objective function cell is filled up like this, and here just this 25 cents, I factorize it over it. It is not necessary. Anyway, you are comfortable with that. After this, we go for the constraints, and the constraints are similar to the previous one that we had, even easier in terms of number and also the complexity of the formulation that you have. After we fill up the constraint, we can go for the solver GUI, graphical user interface, to do the final touches. I just finished the constraints regarding the supply points, and here we have for quarter 1, it is quarter 2, quarter 3, and quarter 4. Let's do the constraints regarding the quarter 1 demand point. like always, we start with equal sign, and the constraint that we are gonna do is this one. So x15 minus x56 minus 400, because the demand of quarter one is 400, and also they sent x56 carpet to the next one, so that's the reason we have two negative, because they are outflow, and we have inflow that is x15. With the same logic, we fill out the rest of the constraints. Now our model is ready for the final touches, so let's go for the objective function. 24. We have it, and it is a minimization, so we go for this. The decision variables that must be non-negative. So we have it. Pay attention that we have two sets of constraints. One set is equal or smaller, as you can see with the first four constraints, and the remaining four are equal. So we need to do it in this way. I get these first four constraints that are equal or smaller, 0, and I have the remaining four that are these ones that are equal to 0. And when I solve it, we get these results. Just make them all round to 1 decimal. As you can see here, we have the final answers, and let's check it together. And it says the total cost now it is 5150, and hope I have no typo over there. And okay, let's try our answer on this graph to make a better understanding of the model we discussed together today. Okay, it says that in the first quarter, they must make 600. In the second one, 300. In the third quarter, 400. And in the last one, 400. See how much everything makes sense according to the things that we discussed before. And here it says that sends 200 square yards of carpet to the quarter 2 from quarter 1, and you don't need to send anything from quarter 2 to 3 and 3 to 4, maybe because, oh yeah, see how much it makes sense. Since the production cost at quarter 3 and quarter 4 are the same, and they both have the capacity to satisfy the demand in the quarters, of course there is no need to produce carpets, store them to be used for the next quarter. And I always call this magic of math. When you model it well, the results always surprise us. Okay, so it says for the first quarter, manufacture 600. It is cheap too, and use 400 here and send the rest 200 to the next quarter. And here in quarter two, the capacity is 300, so it makes 300, but the demand here is 500. That this 200 and this 300 satisfy the 500 demand, and the rest is obvious. Each quarter manufacture for itself, and there is no need to use this extra capacity of quarter 3 because quarter 4 can satisfy its own demand with its capacity, and the total cost as it is calculated here, it is 5150. Okay, here we have $50 cost of storing, as you can see here, from quarter 1 to quarter 2, 200 square yards are transferred, so the cost would be $50, and the rest for here we have 100, 1200, 1500, again 1200, and 1200, the production cost. So we have 1200, that is 3600, and 1500, that adds up to 5100, 5100 there and 50 here, so 5150 is the total cost of this problem. And this inventory is done. This in production and inventory problem is done. Good luck.